Welcome to Math with Miss Garrity. Today we're going to learn how to simplify radicals. A radical sign looks like this, and you probably recognize it as a square root sign, but it's also referred to as a radical sign. The number under the radical sign is called the radicand. And the little number that's situated up here by the radical sign is called the root or index number. So if we would have an example, a number that looks like this number, when there is no index or root given, it is assumed that it's a 2. So this value, this number, is asking us to take the square root of 16. And the square root of 16 is 4. Because this root of 4, when you raise it to that radical, that index, you get the perfect square number of 16, which was the radicand. Later on, when you're in Algebra 2 or calculus, pre-calc, other math classes, you may get a cubed root. What's the cubed root of 64? Well, this value is asking for, again, the number 4, because 4 raised to that 3, to that index, 4 times 4 times 4 gives you 64, which is the radicand. And you can have nth roots. The number of the roots can go on. Now, for us in Algebra 1, simplifying radicals is a strategy that comes into play when we are finding answers that solve quadratic functions, quadratic equations. For example, x equals 6 plus or minus the square root of 20 all over 2. This is a solution to the quadratic function of x squared minus 6x plus 4. But mathematicians do not consider this number to be simplified. And here's why. Here's what I'm teaching today about simplifying radicals. A radical expression is considered completely simplified if the radicand has no perfect square factors. Let me teach you about that a little bit. I want to teach you a little property about radicals first so we can maybe understand and move forward. If we have radical A times radical B, these are both square roots because there is no radical sign. If you have two separate radical expressions being multiplied by each other, you can simplify those and put them under one radical sign. And you would do the operation of multiplication to the radicands inside. So an example of that would be, what's the square root of 2 times the square root of 3? Well, instead of having this multiplication problem, we could write the answer as the product of radical 6. Another example, if we would have the square root of 4 times the square root of 4, you multiply the radicands and you can put them under the same radical sign, the square root of 16. Well, wait a minute. We know that. We know that 16 is a perfect square because 4 times 4 and same number of times itself equals 16. So that simplifies to 4. Now, if you look at our previous example, 6 is not a perfect square number. So we would leave that value as is, square root of 6. But let's go back to the square root of 20. A radical is considered perfectly simplified, completely simplified, if there are no perfect square factors in the radicand. But if we look at the number 20, 20 is equal to 4 times 5. 4 is a perfect square. So instead of multiplying two radicals together to get a single expression, I'm going to simplify this by working backwards. Let's go down here where I have a little more room. The square root of 20. I can split that into two radicals, the square root of 4 times the square root of 5. But wait a minute, what is the square root of 4? It's 2. What is the square root of 5? Well, it's an irrational number, so I'm going to leave that as the square root of 5. So the square root of 20 can be simplified to read as 2 radical 5, or 2 times the square root of 5. That leads us to our quadratic equations answers. If we had 6 plus or minus the square root of 20 all over 2, I'm going to ask you to rewrite that as 6 plus or minus 2 radical 5 divided by 2. I didn't change the value because the square root of 20 equals the square root of 5, 2 times the square root of 5. So I just replaced that with a simplified expression. Now, do you notice how each of these terms have a factor of 2? So I'm going to take each factor, I'm going to take 6 and divide it by 2. I'm going to take 2 radical 5 and divide it by 2. And I'm also going to take this 2 and divide it by 2. This is the exact answer that's equivalent to this expression. So we are simplifying radicals. Let's find another example to do. Let's say we have the square root of 18. Let's simplify the square root of 18. Well, something to keep in mind is a list of all the perfect squares, because those are the factors you're interested in. 1 squared is 1, 2 squared is 4, 3 squared is 9, then you go 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, etc. If you can keep in mind, or keep this list next to you, are there any of these numbers that are factors of 18? Now, somebody might yell, yay, 3 times 6. 3 times 6 is 18. You're right. But that's not going to help us simplify this radical, because 3 and 6, neither of those actually is a perfect square factor or number. So you might notice that 9 is a factor of 18. So I'm going to break this into two. I'm going to say the square root of 18 is 9, square root of 9, times the square root of 2. And the square root of 9 is 3. I don't need the radical sign anymore. But I do need to take it multiplied by 2. So the square root of 18 equals 3 times the square root of 2. That's one example. Here's another example. How about the number 50? Let's take radical 50. Well, I know it's 5 times 10. Yeah, but that doesn't help. 50 is also 2 times 25. 25 is a perfect square. So radical 50 is the same thing as saying radical 25 times radical 2. So radical 50 simplifies to 5 radical 2. One more example. How about radical 147? That looks kind of weird. Let's see. Let's go through my list. Is 147 divided by 4? Evenly. That's what I'm asking. Can I take 147 and divide it evenly by 4? No. Can I take 147 and divide it evenly by 9? No. How about 16? Nope. 147 divided by 25? Okay, maybe we can't simplify 147. I'm going to keep trying though. 147 divided by 36. 147 divided by 49. It's 3. And 49 is a perfect square. So what I'm going to do is I'm going to simplify this. Radical 147 equals radical 49 times radical 3. So the simplified radical would be 7 radical 3. There are more rules for simplifying radicals. We are not allowed to have a radical and a fraction in the denominator, that is. And we're also not allowed to have a fraction as the radicand. For that one, if we have the square root of 1/4, this is not considered simplified. But the square root of 1/4 is 1/2. So you could just simplify it by that, writing a half. We also, like if you had 2 over radical 5, that would not be considered simplified either. And so we would have to get rid of the radical sign, or excuse me, we'd have to get rid of this irrational number in the denominator. And that's called rationalizing the denominator. And if you're interested in that, you can watch my next video. And there you go.